the record. Okay, so we are live. Do you want to add something, Sajja, please?
No, you can start.
Sir,
Okay,
I have
so
a last question. The on-site classes are not going on right now.
No. Hello, everyone. So today we are going to start, as we are continuing the solidity from past few classes. So today we are going to start looking at the functions, which we were following the tutorial from the site. So we'll start with the functions and see what are the properties and what are the structures and everything available related to the functions. So that's what we are going to start today. Let me first share my screen. Okay, so functions. Okay, so during our previous classes, we were already using the functions, but we have not discussed functions specific in detail. But we created the function, we passed the argument, we written the value. So we have already done these things, and we have also provided the attributes related to things. So at the basic level, we have already seen when we create a function, we name it give it a keyword function, and the name of the function, whatever the name we wanted to give it, the argument list, which if we wanted to provide something, then we'll provide it, otherwise we'll keep it empty. Access modifier, public, external, and the private functions you can create. There are two other modifiers, view and pure. We'll discuss what these modifiers do, and the return list. So if you wanted to return something from function in Solidity, you have to first specify that I want to return these values, and you have to specify what type of what data type you are trying to return, and then you can return those values. And calling a function, we have also seen this. So just a moment.
Sure.
Okay, so Sajjad, you can unmute yourself. So I'll when we'll go to other links, I'll write a function specifically and show you guys, but we have seen this level of details for the function because we have already done this. Function modifiers, we can keep the modifiers public, private, and the what you call public, private, and external. We can use external. We can use three modifiers. So let me create a function, and then we'll start looking at the. So starting a local blockchain, then I have this. Okay, so now we need to just few steps to set up everything. Sometimes it seems lengthy, but it's quite helpful when you are working in a project which has multiple contracts and everything. So okay, so that's what we are going to do. Okay, so now that's the function. Let's say do something. That's our parameters, which is public, and then we have something to return or not. So what we can do is we can say returns. The keyword is returns. That means we wanted to return something, or we will return something. And when you actually return, you say just return. Let's say 56. So that's normally we do. So why it's saying no suggestion. Okay, so now we have this function, and what we can do is we can call await solidity test forward dot do something. Now this function is just calling a returning a value, so we can it's not a transaction, and we can hold this value over here.
Hardhead gave a warning to make the function pure when we
Yeah,
were combining. It related to the cost that if we mark it as
no,
pure, it will cost less.
no. It's just the explicit mentioning that what this function's boundary has, what this function is doing. So as I'll explain view and pure, I'll explain that for view function, that means it's accessing the state, and pure function do not access anything related to the state. So I'll move, when I'll move to both of these properties, I'll show you. I'll do something. What it does is, okay, so because we have not marked it as a view or the pure, so it's executed as an what you call a transaction. So now as we wanted to see that, let's skip modifier for a while and explain me view and pure, then I'll talk about the modifiers. So what the view function is basically that whenever you have a function which does not modify state level things of a contract. For example, you are not modifying the state variable, you are not emitting event. So that these are the properties. If you do, then your function is not a view function. So if you call the create other contracts, if you call the self destruct, if you send the ether, uh, if you call any function which is not marked as view or pure, any low level calls, if you do all those things, then your function is not pure, then it's a normal call of a function, and it costs you transaction cost. So at this moment, I'm not doing anything, I'm just returning 56, and even this 56 is not for this type of function, even the view is not acceptable. So what, let me u in 256, let's say counter. So I'm just returning the counter. Now you see the error goes away because previously I was just doing 56. But that means a view function is a function in which you will access any state level variable and you will not modifying them. A pure function is a function where you will not access state level variable and you will not modify. So if you are not accessing, then obviously you cannot modify it as well. So in this scenario, in this case, what I just did is I just to show you that how view functions work. View function are the function which can access the state level variable. But if you try if you try to do counter plus plus, then it will give you the error function declared as a view, but the expression potentially modifies the state, thus required non-payable or payable. So that means this function is a view function, so you cannot modify the state. You cannot modify the state, you cannot emit an event, you cannot fire an event, you cannot create any other function, you cannot send ether or anything. So the view function is a function just to access the state level properties of a function. And if you even do not access the state level property, it will ask you to just make it pure. So here in this case, we are not accessing anything from the state level as well. Or let's say we have u int 256 well, and what we are trying to do is returning well multiply by maybe 23 or something, anything. Even in this case, this function is not view function, it's a pure function. Pure function are those functions which do not access state level variable or and do nothing. They are just limited to their boundary, which is their function. So the input parameters, the parameters they are receiving, only those parameters will be used to the calculation or anything or whatever you wanted to do inside a function which has a boundary only limited to that function. That's the pure function. So it's just wanted in this case, you just wanted to explicitly specify that this function will not access a state level variable. And in the view, in the case of view, you will be accessing the state level variable. So calling them is just the simple call. So now as I have changed to view and pure, well to what's the name, check pure function. So I have not compiled it, so let me just mention it here.
Pure function similar to JavaScript pure function where we don't have any side effects like
yes, exactly. Generally, if any of you are more familiar with the redux of a feature, so redux as a reducer of a redux are the pure functions.
Excuse me, sir. I have one or two questions. Can I ask?
Yes, please.
Like when we do not specify in case of public internal or other things, the solidity itself
Considered as a
considered as an internal function. So in case of if we do not specify it like pure and view, so what the solidity will consider it?
As we have seen, solidity considered as a transaction, so it will cost you the gas fee. Argument value is not provided. Okay, we are accepting the value. Let's say I just passed it 10.
So it will be neither view nor pure, right?
Yes.
Okay.
Okay, so value 0 and 230. So what we are trying to do is we are trying to call the two functions. One has a view attribute and another is a pure, and they will not cost you any case, because they are just the view functions, and it will just be standard function call which returns you the value directly. One of the differences, I guess it has not mentioned over here. So what you can do is, inside a function, you can return multiple values. So if you wanted to return a multiple values from a function, you can specify like this, and at the time of returning a value, what you can do is you can specify like this. So basically, at the place where we'll be receiving this value, will have a tuple. It generally, I don't know where in Python it is called a tuple, where you receive a 2 argument values or 3 argument values, however you want it to call. So in our case, what we'll do is we'll call val3, and we'll say that dot multival value 3 So you can see you have received array in your return value, and then you can access your return values from indexes 0, 1, and 1, 2, and 3. So let's say we have written these two values. So the first index is a counter value, second index is a boolean. So what you can do is you can just go ahead and say 0 and 1. That's how you will be accessing the multiple values, multiple return values from your function. So you can, in case of Solidity, we have a functionality where you can return multiple values from a function. So that's one thing. Another important thing is Tval2, what you can do is you can name your variable inside the returns construct. So let's say I name it index, and data, give it any name. So paid is paid, just name it. And what you can do from here is, let's say I created you. The important thing is when you mention variables like this, so they are actually a local variable for your function. So inside your function, you have these variables available, and you can use them directly. Index equals to 4 multiplied by counter, and is paid equals to true. And the interesting part is you don't have to call the return value, because you have mentioned returns and the named parameters inside the return. You fill those values and you do any calculation. Let's say what I do is counter equals to 45 multiplied by 67. Any other functionality, any other calculation you do here. Actually, that's the view function, so we cannot update this moment, but you may do many other calculations over here. These two variables has been updated in the very first two lines. When the function gets returned, the value, the final value of index and paid variable will be returned to wherever you are calling them.
Nishan, can you use the name outside?
No. Just a moment. Let me just check that. Maybe I don't believe so, but let's see. Okay, no, you cannot do this. So if we had, then we must have the key value property over here. So we do not have these key value properties here. That means we cannot do. So the advantage we have is we can create a variable, whatever we wanted to return, and then do the everything we wanted to do, and you do not have to call the return function. Once the function gets completed, function gets ended, whatever the variable values are, they will return. So you don't have to specify them specifically. That's the few things related to the return and the parameters and arguments. So you can specify multiple parameters and you can return. So you can return your structs, and I have mentioned in last class that we have written the struct and enums as well, but you cannot return mapping from your function. So you have to find out anything else. You can return array, any type of data type you have created. You can return your contract address and everything, but not the mapping. That's what we have the pure and view functions.
So
Sir,
can
given the-
you repeat the pure function?
Pure function is a function which does not have any effect on the on your contract. So it just do the calculations. In the pure native, the pure function, when from where it's coming from, it says a function which does not have a side effect. That means this function will not change anything related to your contract or the boundary in which that function is enclosed. So it will not make any changes related to the contract states. It will not access them. It will not change them. It will just do any calculation inside this function. So if there are many times when you need you need to send some calculation or do something related to the contract inside a function, which does not affect contract level states or everything, or not accessing anything. So you just do these calculations inside a function and make it a pure.
Sir, these variables index and is fee paid. These can be used only inside a function, yeah?
Yeah, these are the consider them as a local variable. When you create a variable like this here, when you create a local variable like this, they are just exactly like a local variable to you.
Okay, sir, thank you.
Okay, so now move to the modifiers. So in case of function, whenever we call a function, we have the parameters and we have the return values and everything. There are special type of functions called modifier in Solidity, and they are being used in many places. The most reasonable place for them is to check the function, check the restrictions on a function before calling that function. So instead of providing if-else condition inside your function business logic, you just provide all those restrictions or conditions before those functions inside some modifier, inside any other function, and that function will be called before your function. Once your conditions are matched, then your function will be called. So if you can see here, what we name it as a modifier and give it any name. At this moment, this is the only owner, and you check your conditions over here. If your conditions are matched like this, so if you mention underscore, that means go back and call the actual function. You can call it this way in the form of require, and you can call it in with the if conditions. So whatever you do, so if your condition does not reach to this underscore, that means your function will not get called. So here, if you can see, they have mentioned a function called change price, and the modifier is mentioned over here, only owner. So whenever this change price function gets called, what will happen is this only owner modifier gets called first. The condition will be checked over here. If condition matches, then it returns the underscore. That means call the change price. If it does not, then you will receive error or anything, but your function will not be called. So for us, what we can do is, let's say,
Sir, when this require can work directly, then why do we need to make a modifier using require?
basically, you have a lot of places in your contract where you wanted to apply the same condition, same business logic, or same restrictions. So what you can do is you can place there's that condition inside a modifier and then apply that modifier to your functions. So let's say 4 of your function are, and that's the common thing when you create an NFT or the ERC20. So you wanted to have a few functions which can only the owner of a contract can call. So that's the common thing we call the only owner inside our NFTs on many of the functions. So let's say I have a function. For example, in NFT or ERC, many a times we have address, let's say, treasury address. Treasury is the one who will receive the funds from whatever we receive inside the NFT, and we wanted to transfer that fund to the treasury. So we name it treasury, or we name it honor, or anything we wanted to name. So just the name. So don't worry about it. Update treasury address. And what we can do is, now consider the NFT or any ERC or any of your contract. If anyone can call this function and upset any of the address, so you have created NFT and I have this access to this function, I can call this function and set my address into the treasury. So what will happen is whenever the withdraw function will gets called, or any function, so I will receive funds. So that's mean we should restrict that function to be called by only the owner. So owner can set the address of this on this function or in this contract. So what we'll do is we'll create a modifier and only owner. If you do not have a parameters, then you can skip the parameter list. But general practice is what we do is name it over here like this. I'll show you the parameter one as well. Now what we can do is okay, so what I have to do is I have to call the constructor as well. I have not mentioned you guys the constructor, but for now just bear with me for this one as well. Now what I'm trying to say is whenever this contract gets loaded, or whenever this contract gets deployed, whoever call the deployment, that's the owner of the contract. So we mentioned inside the constructor that the owner address gets the message.sender. So whoever deploys this contract will be owner of the contract. Now what I'll try to do is I'll apply require, and inside the require I'll say message.sender equals to owner. Or whatever you wanted to mention. Now what I'll do is I'll say only owner. Okay. Now, whenever the owner whoever deploys this contract calls this function. Before going into this function, this modifier gets called, and inside that modifier there is a check that it's the true condition that message.sender, whoever calls this update treasury function, should be the same person that deployed that contract. So the message.sender equals to owner, that means that's the true. If the condition is true, then go ahead. If condition is false, then it will throw an error to your contract. So that's how we'll do it. And let me try to run and compile, show you the result. Okay, so for now, just comment all this out. Okay, so let me do one more thing, make them public, so we can access from outside, and I'll show you what will happen. Okay, so first of all, before that,
Sir, who is the message.sender?
whoever they calls the function. Okay, so when hard hat gives us the facility, whenever you try to run the script from the hard hat, you have the function ethers.getSigner. So whoever connected to this, whoever calls this script. So at this moment, I'm calling this a script. So that means my address, the address which is trying to deploy this contract, is the one. So it returns the list of addresses. In the testing mode, deployment local host, we have 20 addresses in the deployment mode. When you will be connected to the public net or a main net, then you have one address which will be connected, and I have showed in the very first or second class how you can deploy contract on Etherscan or the main net. Okay, so when you call the ether.signer, you have the owner. So the whoever calls by default is the first address, so that's the owner. So let me show you the.
So we don't need provider here.
We don't have to provide the because the script is calling from this address by default, so we don't have to specify anything over here. By default, the contract is deployed with this owner address. That's why I'm just mentioning over here, and I'll explain you in detail. Just bear with me. Owner address, contract owner address, treasury address. Now what we'll do is I'll call the await solidity 4 dot. Okay, so just a moment, let me just compile it. So okay, so that's a con. Okay, just let's run this so you guys can see these three addresses, what they are. Okay, so as you can see, owner address is 0fx something 22266, and the contract owner is the same one. Why? Because when we deployed this contract, this address is being used for the deployment. So our contract address, because of this line, is the same as the first one, and this address 2266 is exactly the same from one of the 20 addresses we have. You can see 2266. So when you run the local node, you have 20 addresses, and the very first one is the coming in the very first index. The second one will be coming in the address 1, and you can go on with like ADR2, name it anything, ABC2, name it anything. That's your variable name. So we generally do it as like this. Okay, so that's one thing. Now what I'll do is I'll call const.
Excuse me, sir.
Yes.
Sir, I'm still confused. Where does the owner address go when the contract gets deployed? Like it does go in the message.sender.
Message.send. Yes, it's going in the message.sender.
And when we call the function, how does the contract know who is the one?
Exactly
calling the
exactly like the one when we try to deploy it. So that first address is gets used and it will be the message.sender. So exactly like when I'll call the function update treasury address. So whoever calling this function, so at this moment by default owner, I'll show you, we can change it. I'll show this as well. So what I'm trying to do is address one dot address. So what I'm saying this, the address one dot address should be the treasury address for us. Now what I'll do is we have updated the address, and because the deployer is the owner and that same function is the same address is calling the function, so we will not face any problem in calling this update treasury function, and we will have the updated treasury address. So I'll show, let me show you, because previously it is 0 because there was no address.
So sir, basically this get signer is returning us message.sender.
No, message.sender, no. It gives us the list of addresses available to hard hat. Network connection timeout. Okay. Okay. So you can see we have a owner address, 2266. Contract owner address is the same. Then the treasury address was empty. Again, we are checking that owner address is 2266 and the treasury address is being updated 79CB, which is coming from this address. Now we were able to update it. So that's the how we can see that if someone else is calling this function, so what will happen? So how we can do that? For that, what we can do is, instead of calling function like this, we have a functionality where we say dot connect. That's the specific to the hard hat ethers, sorry. So how you can, that's not related to the solidity or something. So that features provided us by the hard hat framework and ethers. So you say connect ADDR2. So what I'm saying is call this update treasury function from the address 222. Now that's something different. By default, it is like owner. That's by default. So if you do not mention this connect, that means the very first address in your signers list will be the caller of the function, but you wanted to change it. You wanted to do this from any other address. Then you can call dot connect and you can specify the address, whichever address you wanted to use the call this function. Now, because this ADDR2 is not the owner of a contract, So what we'll see is we'll see the error over here because the only owner will get check this function and we'll see transaction failure. We should see. Let's check this out. Okay.
So, but you haven't changed the arguments in the bracket where you write address.
We don't have to. We just have to change the caller. So the caller it should fail.
Okay.
The one who is calling.
And the arguments to after the dot update transaction and in the brackets that will still remain addr1 dot address.
You can send any address. This is the parameter. So you wanted to set this address as a treasury, but the difference is who is calling the function. You have to understand this. The one who is calling the function, this only owner checks will apply to the person, to the address who is calling this function.
Okay.
Okay, so you can see error here, exception while processing transaction, and you can see only owner can call. You can see the exception over here. Why? Because the caller of this function is not the owner. So that's how you can apply the checks over here. So we have in this example, we have touched 2 or 3 things together. One is the modifier. Another is the require, how you can check this. And the third one is how you call this function with any different address inside your script if you are running with the hard hat and the ethers. So it's quite easy to change the address because generally if you are working with the remix or deploying it directly, then it will just the MetaMask, your MetaMask will get open and you can change the address from the remix address directly. How you'll be doing this inside the hard hat and the script. So that's what you have. You can change the address while calling the function. So whenever you do this connect and you provide the address, let's say I provide the owner as well. So that's not a problem because I'm trying to call it with the owner's address. That's the normal because by default that's the caller is owner. So you will not face any error in this case.
Inside argument of connect, you put addr2. Why not addr2 dot address?
Because it's the what you say, it's the function provided by ethers. So ethers understand the parameter, the object. This object is signer with address. That's the object created by the ethers. But the update treasury is our function which accepts the address, and by default whenever your contracts come from Solidity into the type script, that's the string. So if you see what this contract accepts, this contract accepts string, and string is available in addr1 dot address as address. So your address, just to give you guys, the signers return ethers dot get signers. It returns an array of signer with address object. So it's actually a TypeScript object, signers with address. It's not a string list. It's an address, and it has each address has a property address which is a string. So that's why you face this difference in the calling, because the connect is the ethers, connect provided by the ethers. So it can accept the function directly that signer with address object. But this is a function which is converted from the Solidity into the TypeScript. It will accept the address. So that's nothing to worry about in this case. So it will always be like this.
Sir, can we
any other confusion related to this? Yes.
Sir, can we return mapping or struct from
We
function?
can return struct enum but not mapping.
And sir, in this case, in the case which we discussed now, by default the owner is address 0. How we can make address 1 or 2 as an owner?
Okay, so you just don't have to, when you do this, that's how you'll do this. So you have you connect is available to you. So when you deploy it, you say Solidity 4.connect address 1 deployed. So now the address 1 is your owner of the contract.
Thank you, sir. And one more thing I wanted to know that for creating these modifiers, which is the better practice to do, like creating a modifier with require or with if conditions, or it doesn't matter?
That's completely depend on the what you wanted to do. If you do with the if, you eventually have to throw an exception. If you wanted to throw an exception, then you use the require. If you do not want to throw any exception, you just silently go away, that you do not know what will what happened. So let's say
Sir, modifier is like only for when we require same logic over and over again.
yes. So let's say I can specify this only owner at any number of functions I wanted to do. Okay, so what I can do is, if now what you see here is, if I specify this modifier over here, what will happen is, if the condition does not match, you will not receive any kind of a notification, any error, any exception, or anything that your function is not working fine, or you have not provided the right values, or the caller is not defined. It just it will go silent, and you will not and if you wanted to do, then what you have to do is, you have to call else, and you have to call the require. So here we are at the same place. So it's better to go with the require. Only if you do not want to let the user know what happened and just go silent, then you can use the if.
This exception is shown in the console as a console.log, or how it shows this error?
Your transaction will fail if you are using the MetaMask. Your MetaMask will show you the error, and all the errors. That's the transaction failure error. So whatever the transaction failure errors are, that's the same.
So another problem that I was facing, that when I initialize my hard hat project, and with npx, after npx hard hat, I go it with the TypeScript template, and install the dependencies and run npx compile. At that time, it generates types, and when I use those types in deploy.ts, it shows me error that the type contact factory is not assignable to greater factory.
It's just the problem. It's just the problem with your compilation, or your whenever you call it, there are a few problems related to this. Just clean your project, npm hard hat clean. It will clean your project, remove these calls from here, and try again. One. Another is, you might miss the name of the contract you have not provided correctly. So this name of the contract should be the correct. This factory name should be the correct, and then this name should be coming over here. So these are the few things. That's the only things that gives you these factories error. That's the only thing.
Sir, I created 3 or 4 times. I generated new projects, but same problem is I'm facing with.
Just create some example on the Git and send me the link, so we'll verify what the problem is. Send the link in the blockchain or a bootcamp 2021 group, the GitHub link, so we'll see.
Okay, sir, inshallah.
Okay, so what I was trying to show you, yeah. Now what we wanted to do is, we wanted to see if modifier can accept the parameters. So what in this case, I have created a variable called price, and let's say this price is 0.01 ether. So just wanted to show how the amount is coming in. Otherwise, that's not the problem. So what I'll do is require that's not the way. The right way should be the price equals to message dot value. So we can check the value of an ether. So I'm not doing it as a ether value. I'm not sending the value as a ether. I'll send this as an amount. So we just wanted to verify that our condition is working this way.
Not with, and the transaction fails, still the guess limit will apply.
Sorry.
If the condition is failed and the transaction
Gas
will
cost
fail
will,
also.
there will be the cost. There will be the gas cost.
Okay.
Okay, so what we are trying to do is, in this case, we are calling a modifier, but modifier will accept the parameter and check this condition as a parameter. So as I mentioned, that's the not the ideal way you verify the price of the value. You accept this from the message dot value, but I wanted to show the parameter. That's why I'm doing it this way. Here what we'll do is we'll call verify amount, and I'll pass the underscore value over here and just update the price equals to underscore value. Now what will happen is, whenever I'll call the update amount, it will not check who is calling it because we have not specified the only owner, but it will check the value provided is equal to the price. So there is no reason to update it, just forget about it. So it will check if the amount provided is equal to the price, then it's okay, and this function will get called. If amount is not equal to the price, it will gives us the error. So what we can do, okay, so in this case, so we don't have to connect it because it does not matter. Whoever calling is, the amount provided should be the correct amount. So as I have mentioned in previous class, 0.01 ether is not 0.01. It's the 10 raised to the power 18. So what I have to do is ether dot util dot parse ether 0.01. Otherwise, it will not consider it as a correct amount. Okay, so let's say update the counter as well, so we can see if counter is updated after our call. That means we are good. Okay, so as you can see, it works fine because the amount we have provided is equal to 0.01 ether. So counter 1, and we have not faced any error. But if I would have provided the 0.01 ether, so that's the different amount. Even if I provide the 1 ether, that will also be the different because we want equal value. So whatever amount other than 0.01 will be the cause of error. So we'll face the transaction exception, transaction failure.
Vishan, you are just sending a ether amount. You are not sending ether. Am I correct?
No, I'm not sending ether. It's just the ethers.util.parse in it is a function which converts a decimal number into 10 raised to the power value. So because inside the contract we need everything in way. So that's what I'm not actually sending the ether. Thank you. Okay, so you can see the error over here, incorrect value provided. So that's the modifier. So whenever we call the update amount, modifier gets into the place, into the work amount. This value goes over here, and then it appears here, and the check gets checked out and the require function. And if it's okay, our function will go fine. If not, then we'll face the transaction failure exception. So that's how you use the modifiers, and there's a very great use, or we use it in very quite big deal every time we wanted to check our functions conditions. So most of the conditions you provide, if these conditions are being used on multiple functions, so we'll specify those functions over here. And good thing is you can specify multiple require together, so that's not a problem. So if this require gets okay, it will check this one. If this require gets okay, third one, fourth one, so whichever gets failed, your error will that error will appear on your transaction failure. Okay, that's the modifier. Any questions, so we can move forward?
Well, modifier can be public, private, or like that.
No, that modifier does not have any accessibility conditions, because modifier applies on the functions. So function can be public and private. Modifier can apply on any function, because we cannot call from outside. Modifier cannot be gets called from outside. It will only be called by inside the contract. If you call a function, that modifier gets called.
Vishan, can I ask you modifiers? It seems to me modifiers are compile time constructs. They are basically synthetic sugar. They basically put the code at runtime. It doesn't make a difference. Am I right?
I haven't tries to go into that detail for this modifier, but that seems to be. It seems to be because this underscore means put the function over here. You see, but but this modifier gets called for the multiple functions. So I'm not sure. I have to explore, and I'll see if I can come up with the answer next class.
I have a question. Like, if we have a modifier in another contract and we are inheriting that contract in our main contract,
It
so
will be
can we
available.
use?
Yes.
Okay.
Okay, so now we are coming to the fallback function, and the this tutorial has the older way of calling the fallback function. Now it has been changed completely. So previously, when you wanted to send any ether to your contract or any value, or you call a function which is not available inside the contract, so what you can do is you can create a fallback function like this. And whenever you send an ether to a contract, that function can receive ethers on your behalf. But now that gets changed, and the calling of the fallback function has been split into the two functions, receive and fallback. So this is the article you guys should have. I'm passing in the chat as well, and we'll share in the repository as well. So this article explains that fallback function has been split into the two. A function named fallback and function named receive. So you have to write a named function, fallback named function receive, without specifying the function keyword. So the previous implementation of calling is not will not work. But what it does, why fallback functions are being used, that it is called when a non-existing function is being called. So a function does not exist in your contract, and someone tries to call that function because these features are available. You can call a function on a contract without providing a dot operator. So you can call by sending the signature of a function. I'll show you if we get reach to the point. So you can call the function like this way. So if that function does not exist, your fallback function will call. Your function, the fallback function should marked as external. It has no name. That's the old implementation. It does not return anything, and just forget about it because these are not relevant details now. So for us, what we have to do is, let me create another contract. Remove all these things.
So when there is a function which is not available in your contract, how someone can call it?
That's why I mentioned that there is a facility when you can just call a function with its signature. So Solidity provide us this facility. So I'll show you.
And sir, why would someone call a function that does not exist in contract?
That's interesting. The problem is, you have to understand that in blockchain we have a contract which is deployed once. We cannot modify them until we update them or we deploy another contract. Then we'll have another address of that function. So assume we have a contract which is depending on some other contract and calling that contract's functions. So what we can do is, instead of calling that functions directly, we'll call that function's signature. I'll show you from the contract. We have this example available here as well, and I'll show you guys as well. So we call that function and that contract's function as a signature. So what will happen is, we can update that contract, we can change that contract, and we'll call that contract function with signature. So sometimes we have a contract 1, sometimes we have a contract 2, we have contract 3, and we can call that function contract functions directly. So how much theory I can explain by words, it will not be clear once I'll show you until I show you with the example. So I'll show you with the example, and you guys will understand what I'm trying to say. Okay, so 5, make 5. Okay, so we have created the contract. Now what we can do is, previously the fallback function, the construct was like this. Function, there is no name, you call it external, and that's the fallback function. Why we are not receiving error for this? Yes, we have expected state value. If you intended to this as a fallback function, handle plain transaction, use the fallback keyword or the receive keyword. So you have to call the fallback or receive. Okay, so previously, if you wanted to send an ether to the contract, or you wanted to call
just a second, for
Yes.
everyone notice, I have just updated the repository and added the link.
Okay, great. So now what we have to do is, they have splitted this functionality into the 2 functions, receive and the fallback. If you wanted to send an ether to the contract, just implement the receive function. And if you wanted to have a call a particular function, and that function will go to the fallback function. So when you send the call data, when you send the data to your contract, then the fallback function will get called. So receive like this. It should be payable, because receive is specifically to the receiving ether from now. Okay. So we will be actually receiving ether in this function if we have the receive function, and we'll have the fallback function as well. So just to show you guys, let me comment out this receive function and run the fallback only. So it will give you the warning that if you have specified the fallback function, but you have not specified the receive function. It should have the errors. Oh, I have not mentioned the payable over here. Okay, you can receive the warning. So that means at this moment this is warning. Maybe in future they might convert it to the compilation error that you must have to be provide receive and fallback both. So at this moment, whenever you provide the fallback function, they recommend you to add the receive function to receive the payment, not the fallback. But it will work fine. You can send the funds to only to holding the fallback function. So let's do some. Okay, so UN 256. Count receive, count fallback. So what I'll do is I'll just call the count receive plus plus, count fallback plus plus, and as we are receiving funds, so address UN 256. This just to show you guys that there is a difference between both of these functions. We generally don't do the receive, just don't call the receive for both and hold the mappings like this. Just to show you guys what will happen when you call these functions separately. I'll keep all of them public. Receive balance message dot sender, whoever calls this function, plus equals to message dot value. So when we'll receive the funds from this, we'll have this. And one more thing, you can make the fallback non-payable, and it works fine. That means that fallback function cannot receive the value ether. But at this moment, I'm showing you that we can receive ether in both of these functions. So just to show you guys. Okay, so that's the fallback function. Now we have a function receive, which receives the ether. We have function fallback, which also receives the ether. But when we send the ethers to the function, which function gets called? That's the important point, because now they both are separate things. Okay, so first of all, Verify dot get balance. Don't have a balance. Address dot balance. I should do a balance function only. Ethers dot utils dot get ethers dot providers dot get balance. Okay. So this will give me the balance of this contract. It's not an address, it's a contract which will receiving the ether. So I'm just mentioning the balance of it. Now what we'll do is we'll call the, now we wanted to transfer the funds. So we will be actually transferring funds from a particular address to this contract. For that we have let's say we're sending from the owner or address, any one send transaction to on which address we wanted to send. So we'll say solidity.address. So we'll be actually sending the funds to this and the value. Okay. And value will say ethers.utils.parse ether. If I'll say 1, that means I'll be actually sending the 1 ether from address 1 to this solidity contract. Generally, like if you see the NFT contract or ERC20 or any other contract, what you do is you create a function which actually accepts the payment. Let's say you create function like this, add sum, and you make it a payable. So that function should receive a payment. But you can directly send payment to a contract as well. And that's the way you send the ethers to a contract directly. So it will deduct 1 ether from address 1 and send that ether to this contract, the solidity for test 5 contract. What we can do is we can before calling this transaction, we call we'll compile it. So we have these variables available.
So this txt one shouldn't be await.
Oh yes, it should be. Thank you. Okay, so we have receive count. What I'll do is receive balance. Now this receive balance is actually talking to actually this is the mapping. So what we have to do is we have to provide the address inside it. So we are calling this from address 1 so that we wanted to say that address 1 sends the funds to the contract. So in this case, message.sender will be the address 1. I'll provide this addr1 dot address. That's the before, and all those values we'll see after as well. so hopefully everything works fine. Okay, so contract.balance should be the toString. Okay, so now we can see before doing anything, our contract, which is Solidity 5 contract, does not have any ether and the balance of contract is 0. Receive counter is 0, fallback counter is 0, receive balance 0, fallback balance 0. Once we call this transaction, so what we are saying that from address 1, send the 1 ether to Solidity 5 contract. Now you can see our contract has a balance of 1 ether. So you can format it just to understand it. And which function gets called? Receive counter. So we actually receive function gets called, not the fallback one, because we have implemented the receive and fallback both. If you try to send any type of ether or funds to the contract, receive function will get called, fallback will not. And that's for that. Here you can see just to where it is. Okay, leave.
Nishan, you are saying that whenever we send money, always receive function is called, fallback function will not be called.
Yeah, if we have received. If we do not provide receive, then it will give us warning at the compile time, but the function will work.
Sir, if
and
we send the data
fallback will
as well in the transaction, will it go to fallback?
Yes.
Okay.
Okay, now you can see balance of contract is exactly same, but the fallback function gets called. Okay, so whenever you try to send only the funds, then receive will call. But if you are sending the funds with the data or the function call or any other information you are wanted to, you will be sending, then receive will not get called. Let's say we have receive and we have fallback, and then we try to send data. So at this moment we do not have any data. I'm just trying to okay, what's saying invalid hikes. Okay, so we have to convert it into the X value. For that, I have to do some other changes, so that will take us to some other things. So I don't want to go into this. So we can get the encoded function, and then it will encode the value. It will gives us the hex value, and then have just let me try just the if I can send it directly. If it works, then good for us. Otherwise, I'll not go into the detail for this for now. Yeah, it works. Okay, so you have to provide the data in the hexadecimal value, and that data can be any function, any value, any argument which will be available inside this fallback function, and you can use that data inside that function, but we'll talk about it later sometime. So at this moment, you see balance is 0 anyway, balance is 1, but receive function not get called because we are sending data as well with the function with the funds. So fallback function gets called. So you have to understand this of differentiation between the calling of a function with the data and with the value. So we have both receive and fallback. If you send only ether, the receive function gets work. So this is the specific to features or the functionality where you wanted to just send the funds to your contract, use the receive function. Whenever you wanted to call a function, use the fallback function, so that if anything fallback means if nothing gets work, calls the fallback. That's why the fallback function is here for. If nothing gets called, if there is no such function, then fallback gets called, and at least if we are receiving the funds, take the funds as at least if the function is not available. So that's the difference.
Rishan, I have a feeling sometimes they have made this programming language complicated, and it can create bugs. Or am I wrong in this?
In this case?
In this case, if you are adding, that's why they corrected it. They should not have added fallback in the first instance because it's very dangerous.
Yeah, basically, the fallback is that you do not have to control the receiving of payment to a contract via some function. So just send the funds to the function, and who will receive that funds. So that's why they had the fallback function previously, and they also had the feature that you call whatever a function to the contract. If that if that function is not available inside the contract, at least fallback will get called. And it's if you are sending the fund, so it will hold the fund. If you fallback function needs to do something related to this function or not, that's why it was there. But it was creating the mixing, and that's what this example is trying to explain, that what the problem is and how it is mixing calling of a fallback and funds at the same time. That's why they split it into the two. So if you have only funds, just call the receive. If you do not have the funds, or if you have funds with some data or a call of a function, then use the fallback. That's why it is there.
Thank you.
Okay, now the one last thing, how we can call the function which is not available. Okay, so for that, what I'll do is, as they are doing is inside the contract, because we'll be calling it from some function. So just to create the example like this. Just trying to create the dynamic, but we'll create the dynamic way later. First, let's do it the simple way. So that's the example address dot call abi dot encode with signature. So let me just pick it from here, just to. So what you do is you call address dot. So we already have this address, so we don't have to do this. We just do this. Our contract address dot call abi dot encode with signature, and we are calling a function name hello world. Now this hello world function does not is not available. It will return the true and some success values. But what we'll do is we'll send the address of this function, and it will call this hello world function, and we'll see that the value will be this fallback will get called. So now let's come to the, let me just call the compile, and in the script We have a lot of things. What I'm trying to do, I'm trying to just say test the fallback and receive. Okay, so I'll comment this out. Okay, so we have created a contract. So what we are trying to do is we have created another contract, and with this contract we'll just say solidity contract 6 dot, what is the name, test function, and we'll send the solidity 5 dot address where this is the transaction, so we'll call const txt1 equals to await. Okay, so once this function gets called, it will try to call this function hello world from this contract, but hello world does not exist in this contract. But what it will do is it will call the fallback function. Now we do not have message.value because we are just calling this function, so we might face some error. So once we'll run, let's see what happened. Okay, so we have not faced any error, but you see balance of contract is 0, receive count, everything was 0 before, and after, because we have not sent any ether, so it's a 0. But you see fallback counter is 1. That means when we call this function, here the hello world, so actually this contract does not have this function, so that's why what it does is it goes to the fallback, and if it has any ether or if we have to do anything, so it will goes there. So just to make it dynamic, what we can do is, let's say we have add some this function just to show some trying to make it a bit complicated just to understand things. So we have a function named add sum, and what I'll do is instead of and that signature I'll pass over here. Now what we can do is, let's say first of all we'll try to send the hello world exactly as we were doing to see things are working correctly. Okay, so things are working correctly, fallback is 1. Now what I'll do is I'll call add some signatures, right? Yes. You can see the receive and fallback 2020. In this way, you are calling this add sum function without actually using the dot operator or anything else. Now you have the control that whatever contracts coming in, you will add this address and you'll add the name or signature of that contract, and then you can call this function. So this will gives you the great flexibility while creating an application with the dynamic functionality where your contract gets changed and you have to use the new contract, or your contract gets deployed on every call. So that's the functionality you can use when you wanted to call a function of a contract, but that function might not be available at the compile time, at the runtime, and it will be coming on at the runtime from the input of user or something. So that's how you can call these functions. And because this function is available, so this function, actually that function will get called. If that function will not be available, the fallback will get called, and you can do any operations or anything in the fallback function, whatever you wanted to do. That's how you use those receive and fallback functions.
Dishan, basically you are saying in the example, if I'm also passing data and also passing ether, then both receive and fallback will be called.
If you are sending ether as well, basically you are calling the add sum function. So it will actually call the add sum. So it will not receive the ether at this moment because we are using the actual using the function.
No. In the sense we are, if we said specified hello world,
yes,
and we have removed from fallback the payable, remove it.
This?
Yes. Now, if we are sending ether as well as calling hello world, what will happen?
No, it will it will not work because we are sending in ether, and the fallback does not have the payable property, so it will not do anything. It gets it will receive an error.
Receive will not be called.
Yeah, no, because the actual whenever you are sending a signature, the fallback should get called, and if we have ether as well, then it will not match the functionality of this fallback, and it will get failed. The transaction might get failed.
Could you please repeat it?
Just a moment. Let me try. Let me try if I can send the value from here.
So it's mean that good practice is to use fallback as payable.
Fallback as payable if your fallback needs to receive the payment. I'm not sure I can do this. Let me try this one. No, that's just accept the from function, from property. So it should not be like this. Okay, so what I can do is, and now that it gets complicated.
Sir,
What we have to do, is we have, yes, please. What we have to do is, yes, please.
Yeah, I think here we are calling the test function and you are trying to send ethers and it's not payable. That's why it is saying like you can't send ethers.
Okay, yes. So that's the okay, but we don't want it. Actually, we don't want it. So if we make it payable, let's make it payable. So payment will go over here, but then we have to pass it over here as well. So that will gives more complication to this functionality. So it will complicate further. So I'm trying to avoid it at this moment. So just leave it as it is, and keep it as it's simple at this moment. Okay, so because we have to specify the data inside the call as well, and we have to do all those things. So let's leave it here at this moment. So Solidity 6 test function at this moment, and we have this functionality over here. And that's how we call the function and receive, and that's why they have separated those receive and fallback to separately. So we can any questions further related to it?
Yes, sir. That like I have question about the text function call that I don't understand it working.
test function call, basically what we are trying to do is we have a kind of a factory function or a proxy contract which does not do anything by itself. What it will do is it basically call the functions of other contract, but those contracts are not in production yet. They will come in the future. So how we can do those things, but deploy this contract today, and the function we wanted to call on a contract will be deployed in the future. So what we are trying to do is we are saying that we have an address and we will receive a function signature, whatever you wanted to send, and then this contract will call this contract address and the using the signature of this contract. So functionality will already be there. Once we deploy this contract in the future, what we can do is we can pass this name address of this contract and the function name of this contract. So this solidity 6 does not needs to be changed in the future. Let's say if we had implemented it like this. And then AC dot add sum. What it will do is it will make it strict. It will make it strict that you can only call the solidity 5 contract and you can call its add sum function, nothing else. In future, if your requirement gets changed, your contract gets changed, your function of that contract gets changed, you will not have the feasibility. What you have to do is you have to change this contract and deploy this contract as well again. So in this case, we have the flexibility that we don't have to do these things here.
So this
Just
function is doing that it gets the contract address, and then the contract address have a function that that name we will provide, and it will call that function.
Yes.
Okay.
Excuse me, sir. I have like two questions.
Yes.
One thing, like, sir, this way of calling functions is known as delegate calling, I think.
Yes.
Am I right?
Delegation. Yes, delegation.
Yeah.
I haven't went to the delegation part at this moment, because there are many things we have. The difficulty level of I have already included the many things which is at this point is not as easy for you guys as well. So delegate will add another layer of it. That's why I have avoided it at this moment.
Okay, sir. So another question, sir. You mentioned about the receive and the fallback. If we don't have those functions and we try to send ethers to a contract, then it will not receive it.
Yes, it will not receive it.
Okay, sir. Thank you.
And what will happen to
ethers will be wasted? Yeah, ethers will be wasted.
Wow.
Because I somewhere read that they developed this functionality just to avoid waste of these ethers.
Just
Sir, now I have another question that I have worked on an
yes.
NFT contract before. So there was no receive function. If we like do a mint, we just add the value and it send it to the, and the function is payable. It just send the value to the contract and contract stored it. And then we have a withdraw function. And when we withdraw,
that's a different thing. That's what I have mentioned. If you wanted to make a payable function yourself, that's the complete different story. You make it a function payable.
Yes, like if
yes, that's the one
if
thing.
we do this,
you make that's the normal thing. Then this function should receive the funds. If your function, if your contract does not have a payable function, and even you wanted to send the funds to the contract without making a function as a callable function, so you will just transfer the any funds to your contract, like you transfer the, like, let's say you have a Ethereum address, I have Ethereum address. If I wanted to send you ether, I'll have your address and I'll send ether to your address. I don't have to call any function, you see.
yes.
But if your function has if your contract has a function is payable, then I have to actually call this function. There's a two different things. So
Okay,
instead of
now I
calling this function, what I can do is I can directly send the ether on the address of a contract.
Okay, now I understand.
And you do it and you receive it in the receive function.
Yes. So why it's a compilation? There should not be a compilation error, at least.
Sir, the error is in our script, deploy script.
Okay, so yes. Okay, so reverted without a reason string. So when you try to send the funds to a contract which does not have a receive or fallback, so it gets failed. So it's clear that if we do not have a payable function, then it will get failed. So there are too many parameters. So that's why I just try to check that if we are on the right track or not. So that's what we have a receive and fallback as, and contract will not receive the value if there is no such thing. Okay, I think we should.
Ethan, we should stop for now and wait for the next class.
Sir, I need to ask
okay.
2 questions quickly for regard that are related to last class. First question is that I want to ask, can we connect hard hat with Ganache? Because I want to save, progress of my deployed contracts. If I am running local node, then the moment I close that node, it will, like, all the data will disappear. So can I connect hard hat with Ganache the way we do it in Truffle or using Web3?
I believe so. We can do it because the local node work on the local host and the port. So you can specify here the information related to the local node like we do with the mainnet or testnet. I haven't tried this with the Ganache because I had this local blockchain available, so I didn't try this. But that's not a problem because Ganache set up the local node of a blockchain. And it is available on localhost and the port, so it should be, and I believe so you can do this.
At the moment it is connected, but it's not allowing me to save the data like the way in normal Ganache we are doing it. Like on any later stage, if we want to access the progress of project, we can. But Hardhat is connected, but it's not showing. It's not allowing me to save the progress.
That means Hardhat is creating a separate instance of this Ganache on Ganache somewhere. So you have to check this out. It should be because Ganache is a separate node. Hardhat is just connecting to a local node. So you can connect Hardhat to any node, and once the Hardhat is done, your Ganache can save everything. It should be done. I haven't tried this, so I cannot say for sure at this moment.
And sir, my second question is that I'm running a node with the Hardhat node, yeah. And can I access the functions of that deployed contract on Hardhat node with Web3?
Which for contract?
Like any contract which I deployed on Hardhat node. Yeah, like on that local node of Hardhat. This is the second question.
If local node is running, you have a deployed contract A to the local node. Then you try to run another contract which is accessing the contract A. It's possible.
No, I'm not running another.
If node should be node should.
I'm just accessing the read and write functions of that deployed contract using Web3.
Yeah, that's what I have mentioned in using the Web3.
Yes, because here my read functions are working properly, but when I'm trying to trying to write, it is giving me some. Yeah, but when I'm trying to write, it is giving me some error which I am unable to find on internet as well.
Basically, what you have to understand is Web3 you are trying to do is you are running a web client and you are trying to connect it with the node, right? That's what you're trying to do.
Yes.
So that's the simple. Either go with the if you're doing with the Web3, you have to use the create the contract object, provide the ABI and the address. All those things have been done.
Exactly, yeah, all those things done, and it is reading well. Like all the read functions are there.
So what's the problem?
I cannot write. When I write, it gives me error that chain is not supported. I have tried different chain ideas,
Chain
but
is
it's
then that's the something you have to check that out. Either try with the ethers.
Yeah.
Write should be the this should not be the problem with the write. Must be the problem with some deployment, or must be the way the node works, because at this moment we are running this node and we try to we updated we call the contracts and everything, and it was working fine, so it should not be the problem.
Thank you,
Sir,
sir. Thank you so much.
sir,
No
can you
problem.
send the uh, code that is used to uninstall the uh, hard hat globally on the chat?
Basically what you have to do is you have to just call this line npm this is the command.
Okay, so oh, I have called it. Okay, will see, because I have when I run npx hardhead, I get all the function lists that like a test and
No,
everything.
it's the node module, so you have to uninstall with npm uninstall.
Sir, one question. Which one is better, T or EtherJS?
At this moment both are trying hard to capture the market. Ether has been latecomer, but captured the market quite well. So connecting with the hardhead, and hardhead is being used by many bigger projects now. So that's why you can do the match that where the things are going on. But we cannot say for sure at this moment. Both have the good functionalities.
Thank you, sir.
Ishan, thank you so very much for your precious time. Thank you
Thank
from
you, sir.
everyone. Thank you.
Thank you, sir. Thank you so much.
Okay,
Bye,
thank you
bye.
guys. Let me stop the live streaming, stop the recording.